and gentlemen, have a seat. Pete, Michael, y'all. Sit. Few things. First, I do have a worksheet that I'm going to be handing out in a few minutes. I'm also giving a gentle reminder that conversations that are going on now can have a bookmark put in them for the next 40 minutes. I wanted to mention, whoops, forgot a word, la. Poor guy's name. Has anybody ever heard of Saint Claude de la Colombière? Okay. He's not incredibly well known. He kind of should be. Saint Claude de la Colombière. You've all heard of hopefully since our school is named after it, the Sacred Heart of Jesus. And to which saint was the Sacred Heart of Jesus particularly revealed? Let's quiz your Catholic knowledge. What's that?
Saint Margaret or something.
Saint Margaret Mary. Saint Margaret Mary. And her spiritual director, the priest who she went to confide about the Sacred Heart and such, and the one who believed her was Saint Claude de la Colombière. He's a saint in the. People are chit-chatting. Stop. He was a saint in his own right. People really didn't know that. They knew he was a holy priest, but they decided there are lots of holy priests out there, so what's extraordinary about him? They found his writings after his death. I mean, he was well known later on because he was associated with St. Margaret Mary, and he helped to promote the Sacred Heart. But they found some of his writings after his death, and it's not that long. I gotta read you one thing. I don't know if you're anything like me, but when you read the lives of some of the saints, they just seem to live a perfect life from beginning to end. Where they said, wow, they were almost levitating from birth, and they never committed a mortal sin in their life. Venial sins rare, if any. Blah 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 blah. And my wife and I had both read stories like that and said, I love the story, it's inspirational. It's a little hard to relate to because I'm not there. I know what it's like to commit mortal sin, and it'd be kind of nice if I had somebody else who could relate to that. Saint Claude de la Colombière, holy priest, but he was plagued by a sense of his own inadequacy, and he was acquainted with his own sin and his own failings. He wrote, I'm just going to read this little portion that he wrote. Saint Therese of Lisieux wrote along these lines, and I think she actually borrowed from Saint Claude de la Colombière when she was writing this stuff. This is a prayer that Saint Claude composed. I have it on the back of some. We have a relic card of Saint Claude de la Colombière if anybody's interested. We can. My lovely wife can print off a few, if I know how many. It says, Lord, behold the soul that is in the world, so that thou may exercise thine admirable mercy to make it shine before heaven and earth. Others glorify thee by showing, through their fidelity and constancy, the power of thy grace. In other words, by living this perfect life. And how sweet and generous thou art to those who are faithful to thee. As for me, I will glorify thee by manifesting how good thou art to sinners. In me, thou wilt show that thy mercy is superior to all our malice, that nothing can exhaust it, and that no relapse, however shameful and however culpable it may be, should make a sinner lose hope in thy forgiveness. My beloved Redeemer, I have offended thee gravely, but it would be worse still if I add to my offenses the horrible outrage of thinking that you are not so good as to forgive me. In vain, your enemy, who is also mine, sets new snares for me daily. He may cause me to cast away everything except the hope I have in thy mercy. Even though I fall 100 times, and my sins were 100 times more horrible than what they already are, I will always continue to hope in you. There's a longer version of this, which basically says, I've sinned gravely, no matter if you had all the sins of the world on your soul. And I don't know if you've ever been in this position. I mean, if you haven't, praise God. But if you have, if you've been in a state where it said, I just made a train wreck of my life. I just made a train wreck of today, of my soul, of, this is bad. And he's been there. St. Claude has been there. And he said, the devil can take away everything, it's kind of like Job. He can take away everything that seems good in my life. Now Job had everything taken away, but didn't sin. And he said, I'm not so lucky. He said, the devil can take everything physical away from me, and he can even lead me to commit mortal sin. I can even lose your grace. I can be out of a state of grace. But I will continue to hope in you. There's no sin so horrible. There's no number of repeated sins so bad that God is not willing to save you. He's saying, like, if I sinned 1,000 times, and they were all mortal, and my soul were as black as ink, I would still hope in you, because you put that hope in me. The scripture says, those who hope in the Lord will never hope in vain. He puts the hope in. So he said, like, they say, well, can the devil lead me to sin? Yes. I mean, it's my fault, but he can lead me to sin. Can the devil take away everything that's dear to me? Yes. The one thing the devil cannot take ever is the hope that God will save me in the end. If you cling to that, and he was saying, like, couldn't the devil just batter me away and finally take away that hope? And St. Claude said, no, because God himself put it there. It's not our strength that's keeping that hope alive, it's God's strength. All we have to do is say yes, and God will carry us the rest of the way. I mean, I don't know about you, but that I needed to hear that. Because if I've, there have been times in my life, and I don't want to belabor the point, but it's been a train wreck, and I've said, and it's usually a sin that's been repeated or something like that. All of us are kind of familiar with. Has anybody ever gone to confession and said, okay, you might as well just type up a laundry list, because, okay, these are kind of the same sins I've been confessing for the last 10 years. I was like, I am so sick of these. And some of the bad ones that come back, you don't have to confess that again. I really don't want to confess that again. Please don't make me confess. Okay, I'll confess it again. And then again and again and again. But no matter how many times it happens, you can still hope that God will forgive you in the end, that God will save you in the end, because God puts that hope in you. The devil cannot take, and the older prayer it's twice as long, but there was a great passage in it. In vain does my enemy and yours seek to take this hope away from me, because you put it in there. Therefore, I will continue to trust you, even if my soul is dark as night, even if the sins pile to the heavens. I will still hope in you, and I am assured of my salvation, because you put that assurance in me. Like, okay, I can do that. Yeah.
Maybe you said this already, and I didn't catch it, but where was he from?
France.
Oh.
St. Claude de la Colombière. Yeah, not a bad question. And St. Margaret Mary was from France too. Kind of a really funny aside. St. Margaret Mary, one of the things she offered up to God during Lent and for a penance was eating cheese. Like going out of her way to eat. She hated cheese with a passion. And so eating cheese was a mortification. So she said, all right, for you, Lord, I will eat this cheese. I was kind of like, who eats cheese? This is like, it's like hating donuts. Who does this? Then I realized it was in France. So they have all these like icky, like gooey cheeses over there, and some of them, okay, that didn't have chortle. So there are probably some people in here who love French cheese in here. I can't stand French cheese. I love the American cheese and German cheese and English cheese. So that has nothing to do with anything. I just wanted to lighten the mood a little bit. All right, take out your notes, please. That was a weird digression, but whatever. So we learned about the Sacred Heart, God's infinite mercy, and cheese. Let me see.
I try not to.
Yeah. Bless you. Try to write this down. Wakey, wakey, y'all. Sometimes literally. Notes out. Try to write that down. I'm going to have a couple examples today. This is one. I printed off the worksheet that we just did. I want to estimate, let me put a little asterisk here. I want to estimate using all Riemann sums. There are 5 different types of Riemann sums. Jack, name me one.
Upper sum.
Yeah, give me another one.
Lower sum.
Pete, give me the next one.
Trapezoid sum.
Trapezoid sum, next one. Midpoint sum, and finally? Simpson's rule, correct. Upper sum, lower sum, trapezoid sum, midpoint sum, Simpson's rule. Those are the 5 Riemann sums that we're going to be using. N stands for what? It's from yesterday. Yeah. The number of slices, the number of rectangles you're using. In this case, it's going to be kind of boring. So let's do it. Grab your calculators, you'll need them. Not as much as you will for the next problem. So what do I do first? If I threw this on a worksheet, which I will, or if I threw it on a test, which I will, how do you do it? Where do you start? The area under the curve, what would be helpful for us to do first? There are 2 different ways I'm actually going to do this, but give me one suggestion. Yeah, good.
Start by actually graphing it.
Graph it. Yeah. Let's graph this thing. How? What shape is it? Oh, math people. So you remember this from pre-calc. Actually, the pre-calc people might actually remember this. Max. What degree is it, first of all?
4.
Degree 4. Is it a positive degree 4 or a negative degree 4?
Negative.
Negative. Why?
Because it's negative, right?
Right. The height multiplier is negative. So what shape are we talking about here? I'm opening this up to anybody. What does a negative degree 4 look like? Yeah. It's an M shape. Correct. A negative degree 4, a positive degree 4 would be kind of a W. A negative degree 4 would be an M shape. In theory, it would hit the x-axis 4 times. It doesn't have to, but it might. Can somebody tell me how to graph this thing? It's a good thing to know how to graph things that are not lines and parabolas. There are ways to do it, but you have to go searching for special points. And if we're all completely desperate, we can make a table. But can you find some special points for me? Anybody? So, Polly, help me out here. What sort of special points can you find in any graph? Like if you just say, here's a graph, what sort of interesting points would be of note in a line, parabola, blah, blah, blah? X-intercepts, correct? And what else? Along the same line. A y, how many y-intercepts? 1. Why? Why singular? You're right. There's only 1. And there can be only 1. Why? Jack, why?
Oh, sorry, what?
Why is there only 1 y-intercept? Why not multiple?
Only crosses the y-axis once.
Right. Why? Why not twice? How do we know that it'll never cross the y-axis twice?
I don't remember.
Okay, Pete?
How do we know?
How do we know that this particular thing will not have, will never have more than one y-intercept?
Uh,
I'm opening up to anybody, I'm
Is
just,
it because most of the 4th degree so it kind of curves up and it just swoops down and touches it and then it just keeps going?
true. Now, we're kinda lucky that we know it's an M shape. Is it ever going to bend back and hit the y-axis again? Why not? Yeah.
Wouldn't be a function otherwise.
It's not a function if it does that. Function is the vertical line test, and the y-axis is a vertical line. So if it has more than one y-intercept, they're lying to you about it being a function. It can't be a function. So, y-intercept, how do you get a y-intercept, John?
Set x is equal to 0.
Set x equals 0, go for it.
So it just be 0 plus 0 minus 36.
Correct. So y equals
Negative 36.
negative 36. Everybody see we got that? Plug in a 0 for x. So on our graph, I'm gonna kinda wimp out here. Negative 36. I at least have a point, and you don't have to do 36 dashes. Any other points you could find? That was the easiest, yeah.
Well, if you do magic pair,
Ah, magic pair, which is, by the way, possible. You know, magic pair is a type of what? Factoring. Does this thing factor? And by the way, we're talking about x-intercepts, so how do you get that again, Pete? How do you get x-intercepts?
Set y.
Set y equal to 0. Let's do it. So we've got 0 equals negative x to the 4th plus 13x squared plus negative 36. Okay, math people, does that factor? How so? Yeah.
well, I did magic pair, so it's 36x to the 4, and then
Okay.
you can split that into 4x squared and 9x squared.
That, by the way, does work. I'll show you that it takes a little longer. If it works, by all means keep it. Hint, magic pair usually only works with degree 2. This has the structure of a quadratic, although it's bigger than normal. I'll show you what, do you remember the 7th factoring method called substitution? If you did u equals x squared, it would look like a quadratic and you can do magic pair. You can also do it straight away if you want. However, there's actually a quicker way, believe it or not. And by the way, nothing against magic pair, I like magic pair. Especially since I finally found the name. Michael, how do you factor this thing? What's the first type of factoring you always look for? Is there one? Second?
No. Yes, I don't know.
Don't read my face.
Negative 1.
Ah, ha, ha, ha. Thank you, don't whisper. 0 equals negative 1. Michael, tell me what's left over.
What is x to the 4th plus
Uh-huh.
negative 13x to the 2nd plus 36?
X to the 4th minus 13x squared plus 36. That unfoils. Anybody tell me how? It's negative 1 times, what is x to the 4th split into evenly? Julie, see, Sean, take over.
Squared.
X squared, x squared. What's your numbers add up to negative 13 and multiply to be 36? Do them multiply by 36, it's easier. What's your numbers multiply to 36 that if you put them together, they're 13? Go.
Would be -9, -4.
Negative 9, negative 4. Do those factor? Max, take over. So these guys.
1x plus 3x minus 3.
What technique is that?
The thing.
Yeah, what?
And x plus 2x.
Oh, whoa, whoa, back up. What's the name of it?
I,
There's a minus sign in there. What's the answer to a subtraction problem called? Sum is addition.
yeah, yeah. The difference.
Difference of
2 squared.
difference of 2 squares. Good. So what was it again?
X plus 3, x minus 3.
Keep going.
And x plus 2, x minus
Good. The -1 is kind of irrelevant for solving. It's very relevant for graphing. But it's not relevant for solving. Can somebody give me the 4 solutions? Polly, help me out here. Rattle off the 4 solutions that this will give you.
X equals -3.
Yep.
X equals 3.
Uh-huh.
X equals -2. X equals 2.
Correct. Single, double, triple roots?
Single.
They're all single, correct. No bounces, no swerves. So just single, I'll actually do the dashes here, just for showing the thing off. So there's a root at -3, at -2, at +2, and +3. So what's gonna do, you said it's an M shape? Is it gonna start from below or from above?
It's gonna start from below.
From below. What's gonna happen?
It's gonna hit -3.
Okay, is it gonna go through or bounce?
It's gonna go through.
Through, because it's a single root. Do you think it's gonna go very high up or no? Why not?
Because I just go back down to -2.
Right, it doesn't have much time before it goes back down. Now what's it gonna hit?
-36.
Correct, it has to hit -36. And then what?
And then 2.
Up to 2, and then? Do you notice that this is the same space as this? You can guess that they'll probably have the same height. Not always, but usually it's a good guess. So again, oops, got an arrow. They are trying to estimate the area from x equals 2 to x equals 3. In other words, they want this area. Does that make sense? Actually, I'm gonna change this. I don't want n equals 1, because it just occurred to me that's an incredibly dumb problem. I'll explain why in about 30 seconds. But I would like to do n equals 2. What does that mean, Jack?
We have 2 slices.
2 slices. Now, how wide is the entire interval that we're playing with?
1.
1. So how big would each slice be if we're using 2 of them? Half. Here's what we're about to do. I'm gonna enlarge this so we can actually see what we're doing. So there's this graph that's coming up, peaking and going down. Supposed to hit here. So here's 2, here's 3, and then where would I have to do the cutoff for the next slice, Michael? Like, how far over should I put a mark for the first slice? Don't work too hard. Well, I need 2 slices. How far over should I put the line?
Like a half.
Yeah, 2.5. So the next point, it's 2.5. I'm sorry, I can't do the decimal, it just doesn't, yeah. So you can do it in decimal if you want, but, yeah. So, there should be a height there. Grab a calculator, here's when you're gonna need them. I want to find, where can I erase? Let's get this out of here. The Riemann sums include the upper sum, lower sum, and so on. Upper sum. Talk me through it, Pete. Upper sum is, how do you get an upper sum? Like, what are they talking about?
And where you put like a rectangle, in like
To cover the top or to cover the bottom?
the top.
Cover the top. Does everybody see, like, when I'm gonna make a rectangle on this first slice, I have 2 choices for my height. I've got the lower dot or the upper dot. So for an upper sum, which one do I do? Pete, do it again. So which of these 2 dots do I use for my height?
5/2.
Yeah, the upper one. So this is going to be the upper sum. I just need to find out something. How high is that? Can somebody tell me how to get it? Good. Yeah.
It's a max, so you can maybe take the derivative of the.
You definitely could, and that would work. There's an easy way. I just want to find the height, period.
Just plug it in there.
Plug in 5/2 to this thing. On your screen, it would probably be helpful. Negative parentheses. Oops, that wasn't parentheses, it was an 8. 5/2, you can do 2.5. to the fourth power plus 13 parentheses 5 over 2 parentheses squared plus negative 36 or minus 36 if you must. What do you get? Give me the decimal first. I'll check and see if it's right. We got it? Be brave. Somebody launch their answer. I want to make sure I typed mine correctly.
99 over 16.
What was the decimal?
No.
Oh, does yours go fraction automatically?
6.1875.
6.1875 is the correct answer. And the fraction is 99 over 16. I'm going to mark that. So somebody talked me through how to get an upper sum for this. The height is annoying because it's a weird fraction, but we can still use it. Let me see. Max, take this one. How do you get an upper sum? I've got two slices. Oh, by the way, what's the height of the other slice going to be?
99 over 16.
And again, 99 over 16, because it uses the higher of the two. Everybody see that the height works for both of them? Because smack dab in the middle is going to be balanced. Yeah. So, what's the area of this slice? First of all, what's the base? It's
Well,
right.
It'd be 0.5.
0.5 times
99 over 16.
99 over 16. I suppose they should be consistent and put 1/2 here. Okay, that's one slice. How do you get the other one?
Then you do
Plus.
0.5
Or 1/2.
times 99 over 16.
It is a complete coincidence that both of them have the same height in this particular case. This just happens to be a very nice function. Usually that's not true. Usually you can have like 6 or 7 slices all with different heights. So, type that in. At this point, here's where your calculator can really become your friend. So it's 1/2 times this thing. Oops. There's a sneaky little way you can get the answer, even without a calculator. You might be startled at the answer when you're done. What'd you get? What's your final answer for the upper sum? You might be a teeny bit surprised. What'd you get? See break. What's that? What is that? 6.1875. You got 99 over 16. Weird. Why? What's up with this? Well, yeah.
Well, I guess you could say 1/2 plus 1/2 is 1.
1/2 plus 1/2 is one of these. Yeah. So you can just add, or you can undistribute the 1/2 and have 99 over 16 times 1. Yeah. So in other words, this is your upper sum. So it's equal to 6.1875? Yeah. Is everybody okay on finding that? That's what you're going to be on to do on the worksheet and on the test for Riemann sums. Whatever the graph is, I would suggest graphing it on paper first, so you know what slices you're dealing with, so you can picture it. Lower sum. This is going to be quite interesting. Dealer Station, take this one. What would I use for the height of the lower sum on this one? 0. It is an incredibly boring slice. It's going to be the base times the height. What do I use for the height on this one?
0.
Also 0 on the other side. Of these two, I choose the lower of the two heights. This is going to be kind of a boring dud problem, but what's the final answer? 0, yeah. The lower sum, the decimal of 0 is 0, by the way, just in case anyone wants to know. Upper sum, lower sum. Good to go? Have your calculators ready. Jack, how do you find trapezoid sum?
It's the average of the upper sum and lower sum.
Right. Take the upper sum and lower sum, add them up and divide by 2. Find the mean, the arithmetic mean. Go for it. What do you get? You can give me a decimal or a fraction, I don't care which.
Is 6.18.
Okay.
Hold on, I'm just.
Okay, go ahead. 3.09375, I agree. What's the fraction?
I don't know, just give me, it's 6.1875 over 3.93.
Okay, all right, math people. I am challenging you. 99/16 plus 0/2. How do you divide by a fraction? Go.
Multiply by the reciprocal.
Multiply by the reciprocal. What's the reciprocal of 2? 1/2. Take 99/16 times 1/2. Not as hard as you think. 99/32. To make something half as big, you can either cut the top in half, or you can make the bottom twice as big. It's your choice. Both of them work. You might have to reduce, for all I know. Good. So we've got the trapezoid sum. Midpoint sum. This, historically speaking, is the most aggravating one to find. It doesn't take that long, it's just a little more putsy. So, Michael, take this one. How do you do a midpoint sum? What does that mean?
You're gonna take the middle of the height up,
I'll actually condescend to use decimals this time. So, I'm sorry, say again?
middle of the height up.
Yeah, the middle of the slice, find its height. What is the middle of the slice while you're at it? Where is that? This is 2, this is 2.5.
Oh, 2, oh yeah, 2.25.
2.25. 2 1/4 if you like. Find the height for me.
So you plug that into
Into what?
the equation.
The original equation. By the way, at this point, there's nothing against typing this in from scratch. But if you have like 6 or 7 slices, I would humbly suggest that if you put this in the y= screen, you could plug these values in much faster. You could do y1 parentheses whatever over and over and over and over. Okay. Let's do it. At any rate, whatever you need, I'm going to do that. Hang on a second. Let me type this in. So I'm going to go to y1. If anybody wants to do the same thing, I'm just typing in -x⁴ plus 13x² minus 36 into y1. And now I'm just going to do variables, y variables function y1, and type in 2.25. Whoa, interesting. Give me a fraction for this. The decimal is really interesting. I got like an 8-digit decimal. Yeah.
Please run it back.
Oh, go for it. What do you get? MA?
1,071 over 1,006.
Yeah, 1,071 over 256. That's your height. Nice. So what you're going to do is you're going to do a slice with that height. It's not perfect, but it's pretty accurate. Midpoint sums are usually very good. Let me see. John, take over. What is the midpoint of the other slice?
2.75.
2.75. I want to take an educated guess as to where the height is.
1,071 over 256.
Right. That does not happen all the time. But since this is symmetric, you should be able to do it. Now, let me see. Double check it. I'm almost sure it's positive, but that wasn't even English. I'm almost positive it's true, but I don't even know what I was trying to say. Type in 2.75. I'm hoping it's 1071 over 256, but go ahead. Plug in 2.75. What do you get?
Oh, I have a question.
Yeah. Plug it in. Yeah, go ahead, Pete.
So, I'm just kind of confused, how did you get the height 1,071 over 256 again?
I plugged in the 2.25 into this.
Okay.
And the calculator did a fraction for us.
Okay.
We have a surprise.
1311 over 256.
1311 over 256. We have a higher height. Surprise. It was not the same height. It would have been so nice, but it's not symmetric. It looked symmetric, everything looked beautiful. Don't assume. Plug it in. Even if you think, oh, I'm sure it's fine, plug it in. So you've got height here. This slice is higher. All right, talk me through getting the final answer on this for the midpoint. Noah, take over.
So, for the first one,
Uh-huh.
you could do that fraction, 1,071 over 256
Uh-huh.
times, 1/2.
Right, so base times height, and then 1071 over 256. Okay,
You can add that to 1/2, multiplied by the 1,311 divided by 256.
256, correct. Now, if you want to just do a simplification, this is 1071 over 512 plus 1311 over 512. You just multiply the bottom by 2. Go ahead and add those. 1071 plus 1311. What do you get? What's the unreduced fraction? Have you see what we're doing? Add these up, please. Do it yourself, so make sure you can do it. 1071, there is a common denominator already, so it shouldn't take a lot of stress. Have we got an answer?
1191 over 256.
Right.
Which is 4.652.
It's 2382 over 512, which reduces to 1191 over 256, which is roughly 4.65234375. That's our midpoint sum. So we've got these. Those are our 4 estimates so far. Somebody talk me through Simpson's rule. How do you do Simpson's rule? It's what's called a 3-way average. What do you think? Look in your notes if you need to. What is Simpson's rule? How do you do it? This you'll have to have memorized. Yeah.
Midpoint sum plus midpoint sum plus trapezoid sum divided by 3.
Right. 2 midpoint sums. Think of it being a slice of a parabola. And if you have a slice of a parabola, the inner part is dented more. It's kind of like the mid part is heavier. It's twice as heavy. Midpoint sum plus midpoint sum plus trapezoid sum divided by 3. Go ahead and type those in. I would suggest you not type in the decimals because you never know when this thing is clipping something at the end. So I'm going to do midpoint sum, which is the 1191 over 256. Here's how I'm going to write it. 1191 over 256 plus 1191 over 256 plus whatever the trapezoid sum is, 99 over 32. Parentheses divided by 3. You can type that directly into your calculator and it'll do it for you. 1191 over 256 plus 1191 over 256 plus 99 over 32. Don't forget to put all this in parentheses. Close parentheses, divide by 3. I got an approximate answer of 4.1328125. Fraction, actually it's equal. 529 over 128. But in other words, the area under the curve is roughly 4.13 according to Simpson's rule. Does anyone remember which of these 5 methods is most accurate?
The last one.
The last one, Simpson's rule, by quite a significant margin. This is usually very, very close. Okay, math people, last question of the day. Can anybody find the exact area? Using your calculator.
The integral function.
Integral. Where's the integral function? Hit clear on your main screen. Where's the integral function? Yeah.
Math 9.
Math 9. Go for it. This is your function. So if you're on the old-fashioned calculator, you're going to type this formula in. So negative x to the power of 4 plus 13x squared, whoops, minus 36, comma, x, comma, 2, comma, 3. People on the newer calculators just put in the boundaries of 2 and 3, put in the formula after the integral, and then put dx at the end. Hit enter and let's see what you got. So the exact one is going to be the integral from 2 to 3 of f of x dx. What do you get? What does it look like?
0.1333.
Yeah, 4.13 with the 3 repeating. Is that a fraction?
62 over 15.
It is 62 over 15. That's the exact answer under there. Now, we were lucky. This is a relatively nice polynomial, so you can take the antiderivative without too much. Your batteries are low, recommend change of batteries, that's fine. Okay. Blah, 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 yeah, that's math. I guess it's lower than I thought, it just auto shut off, that's funny. But, look at these decimal approximations. 6.18, we knew the upper and lower sum were gonna be pretty rotten. 3.09 is not that bad, trapezoid sum. Midpoint sum is actually not bad either. Simpson's rule is quite close. 4.132, 4.13 repeating. So if you can't do an exact answer, Simpson's rule is the best way to do it. Questions? All right, give me 45 seconds. Let me go get your worksheets. Be right back. Okay, I'm back. I need to explain the graphs on the front of these.
That's part of New York. Do we have to know where New York City is? No, just the. Thank you.
No problem. Okay. Sorry. Wow. New York City is like just above New Jersey. Anyway. Okay, look forward for a second, please. Look up here. Everybody? Look at the graphs on number 1 and number 2. The graphs you can largely ignore. They're giving you an idea of how far the interval goes. Like number 1, that's a lower sum. And it's not a very good lower sum. 1, 2, 3, 4, 5. Look at the instructions. N is the number of slices necessary for each slice to equal 1. That, by the way, makes the problem easier. What's the value of n for number 1? So that you see the shading thing in number 1 and number 2, you can largely ignore that. That was just them demoing. They're just showing off. So, yeah.
Sorry, I have a random question. Why do we have all, like, what do we get from these estimations when we know how to get the exact answer?
It's just sometimes we will not know how to get the antiderivative.
Oh, okay.
Like there are formulas where they're just so atrocious, where it took a long time to get the antiderivative of logarithm, for example. It was like x log of x minus x plus c. There are some that we do not know how to get the antiderivative, and then we have to use them.
Okay.
So, and there are other times where the antiderivative is such a nightmare, it's just, let's just do simple. Number one, what's n?
1.
Nope. The width of each slice is 1. What's the value of n that would cause that? Look at the interval they gave you. From what to what? From -4 to 6. How many slices is that if each slice is a width of 1? 10. 10. See that? How many slices for 2? 5. Get the idea? So in this, hold on 8th grade, and don't pound again until we get there. This is not due yet. This is due Thursday. Okay. So look over it. You can probably do number 1. Try number 1 just to see what happens. It's actually a really easy one, and you can check your answer with geometry. It's a triangle. Please stand. Arise. And let us pray. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Glory be to the Father, and to the Son, and to the Holy Spirit, as it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, the Son, and of the Holy Spirit. Amen. Alrighty. Somebody hit the stop on there. See y'all later.
Bye, Julia.
Bye-bye.